So in organic chemistry, one of the most difficult things on a test or studying for a test is mechanisms. So here are some tips for learning to draw out mechanisms correctly. So first of all, the flow of electrons is normally in one direction. So if a nucleophile attacks an electrophile, it's going to push electrons up. And have too many bonds right here if it didn't push that up. So it has to push it up, and it can't push it this way. It has to push it up that way. Second, in acidic conditions, a carbonyl is always protonated before anything else happens, before a nucleophilic attack, and that's because it makes a strong electrophile, so then a nucleophile can come in and attack, because a nucleophile attacks an electrophile. Third, it's important to know which groups are good leaving groups. So halogens are good leaving groups, but a group like an OH needs to be protonated into OH2 plus before it can leave. And it's important to keep the starting material or the starting product the same, the starting product charge the same as the final product charge. So if a group is, if the starting product is neutral, the final product has to be neutral. You can't go from neutral to positive or neutral to negative charge. And last, it's important to try to understand the flow of electrons rather than memorize a reaction with 5 or 7 steps. So I have an example that kind of combines all of those tips into one problem. That's a lengthy problem, 7 steps. So first thing is it's a carbonyl, so it's going to be it's going to have a proton transfer at the beginning. And it's in acidic conditions to form that. So that can be the same as this or the same as this. Basically, it's in acidic conditions. So now it has a positive charge there. It's a much stronger electrophile. So now this OH can come in as a nucleophile and that will slide up. Bond will slide up. And there's still only 4 bonds there. And then what's going to happen is this is going to get deprotonated by a weak base, so that's really actually going to be water. So I just use acid to add a proton. Now we're using water, which is the conjugate base of acid, to remove the water, or remove the proton. Second, we need this second OH to attack here, so first what we have to do is deprotonate, or protonate that to make it NH, or OH2. Now this can slide down and have a double bond there, and then this can kick out the OH2 to the water. So then you're left with a compound that looks a little strange. It's actually going to have a positive charge here. And now this OH can come in and attack, and that'll slide up. So almost the final product. The last thing is this has a positive charge, and this is neutral, and the starting material is neutral. So we still have to deprotonate that last H, that last proton. So that is then the final product, and you can see that first thing that happens is a proton transfer, then you have a nucleophilic attack, then you have another proton transfer right here, and then you have another proton transfer, and then you have a loss of a leaving group, and you have a nucleophilic attack and a proton transfer. But it's much easier to understand the steps rather than just to memorize a list of this. So you can kind of think about it, the flow of electrons is not violated anywhere here. The electrons flow up. First thing you do is protonate it, the carbonyl, because it's in acidic conditions. And then we know that OH has to get protonated before it can leave. So OH2, and then that can slide down, those electrons. So that should help if you just follow those tips for drawing mechanisms for organic chemistry. So you may see a problem like this where you have to draw all the intermediate steps. And that's it. How long was that?